Understanding chemical formulas. This is the most important skill you will need to be able to be successful with balancing equations. So let's make sure that all of the parts of a chemical formula in terms of subscripts and brackets that you fully understand. Number one here, it says consider the molecule of water, H2O, even drawn it. So one oxygen bonded to two hydrogens. That's a molecular compound. Pretty straightforward to see that that compound contains two hydrogens and one oxygen. No brackets, nothing complicated. Now, as the compounds get more complex, your skills become more and more important. Number two, when chemical formulas contain polyatomic ions, you must multiply the subscript outside the bracket by the number of atoms inside the bracket. Let's just say you were told to write a chemical formula for magnesium nitrate. So you go through all your steps. Magnesium nitrate. Chemical formula for magnesium as an ion, Mg2+. Nitrate is a polyatomic ion, NO3 with a 1- charge. So to balance the compound, you need to crisscross. So you end up using a bracket on the outside of that and a 2 subscript. So your final chemical equation for magnesium nitrate will be Mg bracket NO3 taken twice. Now there's two ways to look at that chemical formula. You can look at it by individual atoms, or you can look at it by the ions that are in the compound. And we'll do both. So first, by atoms. There are three separate elements inside this compound. And because there's a magnesium with a number, although it's not written, number 1 after that, there's one magnesium atom. The nitrogen and the oxygen are both inside of a bracket with 2 on the outside. So although there's one nitrogen per nitrate, because there's a 2 on the outside, that 2 on the outside will in fact double everything on the inside. So our compound contains 2 N's, and in fact it contains 6 oxygens. 3 times 2 is 6. Grand total of 9 atoms. If I was going to balance the equation coming up later, and I was going to use skills that would allow me to balance it by ions, I could look at the compound slightly differently. So again, there's one magnesium ion. I'll even write the charge, Mg2+. And then in terms of the anion, which is nitrate, NO3, with a 1- charge, the number of nitrates is indicated by the number after the bracket. So there's 2 nitrates. If you want to look at your charges and sort of confirm that you're right, 1 2+ ion is a 2 positive total charge, and 2 1- ions is a 2 negative charge, which is equal but opposite, 2 positives and 2 negatives. So magnesium nitrate can be looked at by looking at its atoms. You can also look at it by its ions. Next thing, if you have a whole number in front of a compound, like a 2, it will increase the number of atoms in that compound by that factor. So in this case, it would double it. And when you balance chemical equations, what you're doing is you are adding numbers to the front of a chemical formula. So say, for example, in your chemical equation, you had C8H18 as a reactant, let's just say octane. And as a result of balancing it, you opted to put a number 2 in front of that compound. You're adding what's called a coefficient, and that will double everything inside that compound. So inside the compound we have carbon and hydrogen. Carbon and hydrogen. So to figure out how many atoms of each, you need to pay attention to both the subscript and the coefficient. So 8 carbons per molecule times 2 makes 16 carbons, and 18 hydrogens per molecule times 2 would give you 36 hydrogens. and that's the total for 2 molecules of octane. C8H18, basically that's like saying C8H18 and C8H18. You're doubling it. So any number in the front doubles everything on the inside. This particular compound, where it's molecular, I cannot write it by or break it down into ions because there's no ions in a molecular compound. All I can do is list the atoms. Okay, number 4. When there's a whole number in front of the polyatomic ion in the compound, you got to be careful. So, let's say we had a compound, calcium phosphate. Very common chemical compound. So Ca is a 2+, and phosphate is a 3-. Therefore, when you have to crisscross to balance this, you're going to need 3 calciums, and you're going to need a bracket around your phosphate and a 2. So Ca3, PO4 taken twice, is the finished equation for calcium phosphate. Now, in a chemical equation that requires coefficients to be added to that equation to balance it, let's just say, and in the result of the balancing, you end up with a 3 in front of that. That changes everything inside that compound by a factor of 3. So let's list what we would know about the atoms in the compound, and then we'll do it by ions as well. So listing the individual atoms. We have calcium. So there's 3 calciums inside the formula times 3. That's going to end up giving you 9 calciums. In the chemical formula, there's phosphorus. So there's 2 phosphorus. There's a number of 2 outside. There's 1 phosphorus inside. So that would be 2 phosphorus per overall unit. Multiply that by 3. That would give you 6 phosphorus. Oxygen. There's 4 oxygens per phosphate ion. There's 2 phosphate ions, which makes 8, times by the 3 in the front. That's going to give you 24 oxygen atoms. So each subscript gets multiplied by the coefficient in the front. If I was going to do it by ions, you keep your ions together. So there would be calcium as your ion, which is a 2+. There would be 3 per unit times 3, still it would be 9. But the other ion would be the phosphate, staying together as a unit. And there's 2 outside the bracket, times 3 in the front, which would make 6 phosphates. Do a double check, and your double check should confirm what we think is correct. So 2+ times 9 is 18 positive, and 3- times 6 is 18 negative. So they're equal but opposite, and therefore balanced. I'll do one more of those. Say you had aluminum cyanide. Aluminum cyanide, and there was a 2 in the front of that as a coefficient. There would be 2 aluminums. There would be 3 carbons per unit, times 2 would be 6. And 3 nitrogens per unit, times 2 would be 6. That's by atoms. I was going to do it by ions. There would be 2 aluminum ions, 3+ charge, and there would be 6 cyanide ions, which is a 1- charge. So 6 positives and 6 negatives. It'd be balanced, equal but opposite. Now the questions get one step more complicated. And this is where it'd be nice to hear an example. Sometimes in your chemical formula, a letter appears more than once, an element appears more than once, based on the fact that the ion is written to describe its shape, not so much the number of atoms in the ion. For example, say you had cobaltic oxalate. Cobaltic oxalate. So let's work through the steps. Cobaltic is cobalt with a 3+ charge. Oxalate is OOCCOO in its expanded form, and that's got a 2- charge. So when you crisscross those, you're going to end up with 2 cobalt ions, a grand total of 6 positives, and you're going to end up with OOCCOO bracket 3 to balance the 2 negatives, times 3 give you 6 negatives. To compound this further, what if as a result of balancing, or trying to balance the equation, you ended up putting, say, a 4 coefficient in front of that compound? And then you had to list all the atoms and the ions. It can get a little bit complicated if you're not very, very careful. What I would suggest is when your ion like this is spread out, perhaps you could condense it. So I look at that and I see 2 carbons and 4 oxygens. And then that, of course, is still multiplied by 3. And you have your cobalt in the front with a 2 subscript, and then your coefficient of a 4. And by breaking it down like that into its bits, it gets a lot easier. So atoms. I chose cobalt deliberately because the C and the O of cobalt is different, of course, than the carbon and the oxygen in the oxalate. So there's 2 cobalts per unit, the formula unit of the compound. Times 4 is going to be 8 cobalts. The oxygens, or carbons, are the left to be done. There's 2 carbons per formula unit. Times 3 is 6. Multiplied by the 4 in the front, 24 carbons. And the oxygens, you have 4 times 3 is 12 per unit, and then 12 times 4 is 48. 48 oxygens. If you were to do this by ions, it's actually a little bit easier because you're not breaking things down to such a basic level. We have cobalt and we have oxalate. You can write it as OOCCOO, or you could condense it down to the C2O4. So we have a 2 subscript and a 4 coefficient. So that was 8 cobalts. And we have a 3 outside the bracket for the oxalate. Times 4 is 12 oxalates. Check your charges. So we have 8 times 3, 24 positives. 12 times 2, 24 negatives, so it's balanced. And we'll do just one more for practice. So if you had a compound in your chemical equation that was, say, ammonium selenate, you had to write the chemical formula, and then you had to balance the formula. Then you had to add a coefficient, selenate. Ammonium is NH4. Selenate is SeO4 with a 2 negative charge. So it's not balanced. You have to crisscross. You need a bracket around here because it's a polyatomic ion. So you get a final chemical formula of NH4 bracket 2 and then SeO4. SeO4. So by atoms, you would have 2 nitrogens, you would have 8 hydrogens, you would have 1 selenate, and you would have 4 oxygens. If you put a coefficient in the front of that, of course, everything is going to either double or triple or quadruple depending on what you put in the front. I hope this helps. You have practice in your booklet to do. 2 full pages of these to make sure that you have the concept of atoms versus ions fully nailed before we start balancing our equations. Good luck.